All right, so you'll need to set up a development environment for this course with the various technologies that we're going to be using. Certainly, you'll need a MySQL database or some other relational database, as well as a NoSQL database. Typically, we'll be using MySQL and Mongo, but if you want to explore other databases, that'd be great as well. Most of our coding here will be using Java. So you have to have at least JDK 8 installed on your machine. Here's just some pointers of where you can download it and install it locally, but typically you should already have it on your machine. Also, we'll be using Maven as our build tool, and also to download any dependencies, libraries that we might need. So you need to have Maven installed on your machine. Heroku, we'll need to have some kind of server to host the data. Not necessarily to host a web application, but at least to host data, right? That can talk to an actual database and then expose this data through some API. All right. Again, it's not required that you create a web application, but at least you'll need to some data source, or some kind of data source. So you can host it on either Heroku or AWS. Here we should show you how to do it using Heroku. You'll need to create an account on either Heroku or AWS. On AWS, I believe you can get a $100 worth of usage on their servers. Although if you've used them already in some other course, you might have already depleted them. I think if you ask for another, they might just give it to you. At least for 2 consecutive years, they might give it to you. They might say no the third time around. Other than that, otherwise you can certainly use Heroku, which is free, and there's any number of platforms that are hosted on that. You'll need to download the command line interface for Heroku that will allow you to create projects fairly easy. You need to log into Heroku. For creating Java applications, Spring Boot is one of the easier ways to go. It allows you to very quickly create a running server application that hosts some databases and exposes a data model. And to do that, one of the best ways is to install the Spring Boot utility that allows you to type Spring, create me an application, and boom, you have it locally. If you can install it on Mac OS using Brew, or you can point to using Ruby, and this will download and install it locally. Once you have that, you can create an application fairly simple. Just type Spring init, any dependencies equal web, and the name of the application, and boom, you have a working server application. You can go in there and then you can open it up with either STS, or you can build it just using Maven clean install, and you have a running server. You'll need to install MySQL Workbench so that you can connect to the remote database, either locally or remote. Here's a pointer to downloading Workbench. Even though MySQL asks you to register with them, you don't really need to. If you scroll down, you can just go and download it for free. I suggest you download the Spring Tools Suite so that you can program your Java. Although IntelliJ works just as well. It is just we're just going to be working with plain old Maven projects, so either one works fine. You'll just be able to compile from the command line, just Maven clean install. But STS just makes it just a little bit easier. Up to you. Not just yet, but after we come back from the break, we'll actually, it might be right before we go to the break. We'll be using Node.js to just to show you an alternative server to also host data and connect to MongoDB. So you'll need to install Node.js at some point. And you'll need a MongoDB. as your non-relational database. Although if you want to explore other non-relational database, you're welcome to do that as well. You'll need repositories for your, especially for your project, right? So you just create one repository for the whole team. Typically, folks will split up they'll have multiple repositories, one for the server, perhaps one for their front-end client. You need to create them in GitHub, and then deploy all your source code, make it available on that repository. And then as you reach a particular milestone in the course, you need to create a release, telling you that this is the proof of concept, this is the this is the prototype of your application, right? And then the final release when you're done with the project. Okay. All right. Here are some more steps on creating a simple web application using Spring Boot. It assumes that you already have installed the Heroku CLI and that you've already installed the CLI. Once you have done that, you can just very easily type Spring in it and then the name of the application. Once you're there, you can create a very simple index page by creating a web app directory, and in there, just copying and pasting your content, and then you can just start it either from STS or you can run it from the command line. Here's how I show you how simple it is to just deploy it and make it available on Heroku, and then make it available also on your GitHub account. You can rename your application. By default, Heroku chooses a random name for your application. You can change it to something more meaningful, such as CS5200 summer 2018. Or you can open it up also with STS to use it locally. And finally, once you have the application, you can add a database to it, a remote database. So it is required that you have a remote database added to your server. This assumes that you have already created a Spring Boot application and it's already deployed on Heroku, and then you're going to add a remote database to that remote server. It assumes that you already have Heroku installed, Spring, and MySQL Workbench. To add a database to Heroku is fairly simple. You need to go to Heroku's add-on marketplace, and you can search for any number of databases, including Mongo or MySQL, and add them to your server. Then you'll need to actually connect to it. Once you add the database, it'll give you typically it will give you a configuration file, a configuration variable that tell you what the URL is to connect to that database. Actually, let's do it. Let's see. Let's see, where are we? Let's go into NEU. And in there, let's start with CS5200. Let's go in there with 2018. Let's go to summer. And in here, let's create an application. So we can do we can use the Spring command. Oh, that was in the previous one, huh? So what we'll do is that we'll work on projects here in class, and then I'll share that with you on a repository so that you can follow along. So there's no need for you to be copying any source code here. All right, so we'll call this app CS5200, and it will be summer 2018. So having created Spring, you can then go in there. It already creates an application, and in here, let's create a simple web application, web page, just to see that indeed it's up and running. So inside of source, we can create under main, we can create a web app directory, and inside of that web app directory, we can create a file, an HTML file. So we'll do let's cat into an index page. So this is the simplest web page on Heroku. All right, we're done. And to run it, we can run it either from the command line or from within STS. And so let's open it up from STS, from Spring Tool Suite. We'll stop a server that it might already have up and running. Stop. And let's close everything here, and let's import that. Let's say import an existing Maven project, and it's where? Let's see. It's under Annunziato, under NEU, under CS5200, 2018 summer. There it is. All right, let's load that. It found it. Notice that it found it. It sees that this is indeed a project because it found a POM file. How many of you are familiar with POM files and Maven and whatnot? Who's not familiar with POM files and Maven and whatnot? Okay. All right. So it identifies this as a Maven project. Maven is as I mentioned earlier, is a build tool, right? That takes a look at a POM file. POM stands for Project Object Model, and it describes the relationships that your particular project has with other sources, with other resources. In particular, this defines that this is a Spring Boot project, and that means a lot of things, right? For instance, it means that it already has a lot of configuration that you would have to do yourself manually from scratch, whereas Spring Boot it's very opinionated. It makes a lot of assumptions that are typically most cases 80% of the times are the correct ones, right? For most people. If you want to go a little beyond or outside of those assumptions, then you need to override some of those assumptions. But it works for most folks, right? And since we said that it was a web project, it's inheriting certain dependencies that add, for instance, a server, a Tomcat server that you can start it, and it can look at can host content from a particular directory. In this case, the web app directory. Anything that you drop in there will be hosted by this Tomcat server. Also, it generates several classes in here that allow you to very easily get this going. You know, just run it from the command line or from within the IDE. So, for instance, we can just say run this. This file. Notice that it has a main there. How many of you are familiar with Java? How many are not familiar with Java? So most of you, right, familiar with Java. Excellent. So this has a main function in here. That means that this is the executable, the entry point to the application, and so it creates it for you so that you only have to run this one main class, and the whole project is running for you, right? So let's do that. Let's do a run as a Java application. And once this is running, you'll have Tomcat listening at port 8080. There it is. Tomcat is listening at port 8080. And we can hit it. 8080. And you get that one index page that we just created a minute ago, right? So yeah, so just one line at the command line, right? One line of HTML a very simple HTML document, and you have a web application already running. Okay. So what we're going to be doing, what we're going to be focusing later on in a couple of weeks from now, we'll come back to this, right? And we'll start using Java to connect programmatically with the database. The first couple of weeks, we'll be doing it manually. We'll be using SQL to do inserts, updates, deletes, all from the command line as we interact with SQL. But I just want to make sure you have this up and running as early as possible. This can become a real pain to set up, and I don't want this to bite you later on when you actually have to install it. Right? I'd rather deal with that pain early. Right, so that when you do need it, it'll be there for you to start using it. Okay. All right. So that's one of the first. The other part is that we can deploy this to Heroku really simple. We can just say where are we? We can go. Let's go back up. We can just create this as a Heroku application. Just by typing Heroku create. And Heroku will parse the contents of the root of your project and realize, this is a Java application, right? And so it automatically creates an instance for you to be able to host this on their servers. And it generates a repository, a Git repository, that as long as you deploy to that Git repository, it just packages and deploys and restarts the server for you in the remote at this remote location. So we just need to push to this repository. So what we'll do is that first we'll initialize a local Git repo. It needs to be at the root. Make sure you're at the root of your project. We'll add everything that we have. Before we add, we need to make sure that we have an ignore, a .git ignore, to make sure that we're not pushing libraries or jar files or compiled classes. None of that. We don't want any of that in the remote repository, right? We only want source code in our repository. Okay, so that git ignore will be used by Git to make sure that we don't push any unwanted stuff to the repository. Okay. If you do a more on git ignore, you see that this was generated by the Spring tool, saying that, for instance, ignore anything that is IntelliJ, classes, any class paths, any .project, any .class path, any distribution files, any build files. Ignore all that. Don't put that in source control. Okay. We'll come back to this a little later when we look at Node.js projects. We will need a different .git ignore, right? We'll need to ignore other things, right? Anyway, we already have that. We don't need to do anything. We just need to add everything. Let's do a status. We have anything? Okay, so our Git repo says you have all this stuff that I'm not keeping track of. You need to add it. So let's add it. Git add. How many of you are familiar with Git? Everybody? Awesome. And let's do our first commit. So we'll do a git commit first commit. All right. Where do we push it? So when we did Heroku create, right, it created a remote repository for us to push our content. You can take a look at that repo. Oh, it didn't. Maybe I did Heroku create a little bit too early. Heroku create. Okay, now we do. Oh, sorry. There we go. So Heroku created these two remote repositories. We just need to push onto that repo, right? And call them Heroku. There it is, right? So we're going to push master onto the Heroku repo. So we'll do git push to the Heroku master. So now it's gonna push everything to the remote repository. It's gonna package, compile, package, deploy, restart the server for us, and hopefully we can navigate to that remote server once this is. Oh wow, that's Right, so it's downloading all the dependencies. It was successful. Hopefully it's restarting the server, and we can go there. It's launching it, and we can open up the remote server by saying Heroku open. And this might take a minute. Notice the URL, powerful mesa, yeah, like that. And that's our index page, right? It's exactly the same index page that we created earlier, right? So now we have a local server and we have a remote server, right? So ideally, as you're working with your assignments throughout the day, you'll be making lots and lots of small commits, lots of verbose commits along the day as you reach a stable part of the assignment. And then at the end of the day, you commit everything and you push to the remote repo. All right. All right. So let's take a look at how we can add a database to this.